As Florian already said, Jouni and myself are going to give you an introduction into the database backend, basically, of the InTaVia system. So I'm going to skip the slide on InTaVia, as Eva already said everything that's here to say about the project. There are a few goals. Some of them Eva already mentioned. The main goal is to integrate these 4 national biographical dictionaries into one data source, and further enrich that data source with linked open data and the methods of NLP, and then provide an online platform for VA on top of that. Some of our research questions are, so the main, for us, for the backend, the main actually, is if it's actually possible to integrate those prosopographical resources and create an almost homogeneous resource that is valuable for researchers. Then, on top of that, of another working package, if it's possible to enrich that data source with NLP and also with linked open data, what we're actually doing in the backend. And then, if we can gain insights with the methods of VA on such a data set. The tech stack that we're using in the backend, I'm going to run quickly through that, is a fast API, a place graph, so a triple store as a database backend, Jinja 2 for creating SparkQL templates, and Redis for caching, as these queries are pretty costly and part of them at least running very long. So Jouni is going to give you a quick overview on where we are in the system architecture that Eva already showed. Jouni, you're there?
Yeah, can you hear me?
Yes, we can hear you.
Okay, very good, and see me, I guess.
Yeah.
Okay, so hi everyone from me as well. So looking at the overview of the InTaVia that Eva already showed us, on the left-hand side we can see the sources from the past that in our project are in the form of digital databases, which are then integrated or ingested and aggregated in one InTaVia knowledge graph. So next slide. So we are here in this presentation looking at the InTaVia knowledge graph, which then will be accessed by different front-end components or user interfaces, which are tailored for expert users and also for general public who want to access this cultural heritage data. And during the day, you will hear more presentations on the actual user interface components. Next. And if we go deeper or have a kind of in-depth look at the architecture, the system architecture of the InTaVia platform, so we are using the Prefect as a workflow component, or we are running these data processing programs as workflows using this Prefect tool, and they ingest the data in the knowledge graph. Next. And the knowledge graph itself is a triple store, which use RDF for the data, modeling it. We have a SparkQL endpoint that gives us access, kind of very rich access to this complex data. And in addition to that, we have also built this custom API, which is based on Fast API library. And this is for let the web developers to use the data by using traditional REST APIs. And in this presentation, we are now concentrating on the knowledge graph and a bit on the APIs as well. So next.
Okay, so thanks, Jouni. I'm going to give you a quick introduction into the knowledge graph itself now. So we have about 260,000 person proxies. So these are not distinct persons. Jouni, we showed this in the IDM RDF, so in the ontology presentation just in a few minutes. But it is 260,000 data points on persons, basically. Same goes for places, 45,000 approximately, and 170,000 cultural heritage objects that we got from, imported from Wikidata and Europeana. So this is here now the entities per graph. You see the APIS data is on the top left, it's the Austrian data, BS is the Finnish data on the top right. Top left is BiographyNet from the Netherlands, and SBI, the Slovenian data, is on the bottom right. What you see is that APIS, for example, is the only one who has institutions BioGraphiNet has by far the most persons, so more than 200,000. But BS, for example, has a very large share of events, whereas, for example, for SBI, we basically only have birth and death events. So this is entities across datasets. So some of the persons are depicted in two biographical dictionaries. What we see here, for example, this is what we expected actually, that the Austrian dictionary and the Slovenian has about 500 biographies that we find in both. What we didn't expect actually is that there is so few overlaps between the rest of them. So you see only about 60 between the Finnish data and the data from the Netherlands. Also only 80 about between Austrian data and the Netherlands. Then what you see here is a stacked events histogram of the events that we have in the data set. The blue ones are CHO events, so this is basically production events. And you see here a huge spike in the 17th century that's coming from the data from the Netherlands. And the biographical events, the green ones here on the right, is basically mainly Finnish and Austrian data. Then about biases. So there is a huge gender bias in our data set that's coming as most of this dictionary have been written on, so in previous times they didn't really care about gender equality or anything. So what you see here is that, you have to, so we had some problems in the data for BioGraphiNet. That's why there is only these 800 people from the 200,000 with gender. But the rest of them, you see that there is a huge gender imbalance. We also have that across the birth years. And what you can see is there that at least in the Austrian data, you see a slight rise for the later generations. So born in the 19th century, there is a bit more females. Then this is the number of persons, so the number of events per persons. On the left side, you see including CHO events. So you see there are some of the persons in the BioGraphiNet data, for example, that have more than 3,000 events. That's because every CHO object has one event. That's the production event. And on the right side, you see what I already said. There's basically only 2 events per person for SBI and a bit more for BS and B, BioGraphiNet and APIS, so the Austrian data. And that's our data as a social network analysis. So you see the blue one up there is the Finnish data. The big part here is the Austrian data, and you see that there is some connections in between. And the BioGraphiNet data, unfortunately, is currently not very connected, as there is a lot of data on the events missing. But we're working on that with NLP methods. So, and how is the data going into the system? So we have a lot of different data formats as a starter. So SBI, for example, is encoded in TI, then PS data is already in CDOC CRM. Austrian data is coming from a REST API endpoint, and there is Wikidata, for example, that is a SparkQL endpoint. We use then these prefect conversion pipelines that Jouni already mentioned to put all of that data in the target format and store it in source named graphs in our triple store. So every data set gets its own named graph, its own small database within the database, basically. And then using more enrichment pipelines and curation pipelines in this prefect, we put links between those source named graphs in a harmonized graph that we can then use to put all the data together. Then, as I already said, we are using this Jinja templating engine to create SparkQL templates. So on the right side, you see this orange part. This is the REST API. So when somebody requests data from the REST API, this is transformed into a SparkQL query that is again hits the IDM RDF database and then converts the data that it gets back into the IDM JSON format, which is then goes to the user, basically the front end. So, and Jouni is now going to speak a bit about IDM RDF, the ontology. Jouni?
Okay, thank you. So, looking at the data model, the IDM RDF, how the data is represented in InTaVia knowledge graph. So, next. The data model is based on CDOC-CRM version 7.1.1, and that's the ISO standard, an event-based model for representing all kinds of cultural heritage data. And we are applying that. And we use the extension BioCRM for representing the roles in CIDOC or CDOC-CRM based data. And we use named graphs in RDF to separate the sources, for example, data coming from different biographical databases or object databases. And this also helps us to kind of keep track of the provenance of the data. And we use for cultural heritage data, meaning the objects like paintings, we use European data model inspired CRM native modeling of cultural heritage data. So what it means is that we basically model the production events of cultural heritage objects into data. We have also done preliminary mapping of our data model, the IDM RDF data model, to European data model, and we have adapted the interpretation of European as proxy model, which itself adapts the OAI ORE model, which basically means that we use proxies to represent, let's say, persons or groups or places coming from different data sources, and each proxy represents the perspective of that specific source, so some kind of interpretation of that specific entity. And then we are planning to use Provo for provenance data modeling, but this is still a work in progress. And next, we also use BibFrame for references, but that's also a bit work in progress. So here's an example of how we construct the events. So like in CDOC-CRM, we have the event class, which we create, let's say, for a birth event. And then we attach entities for that, for example, the person who was born. And compared to kind of the basic RDF encoding of CDOC-CRM, we also use roles. So we are saying that a person can have a role in the event, or a thing can have a role in the event. And next. So we also attach time span to the event, which is the way that this CDOC-CRM works. And next, we also attach the place using the took place at property. So events happen in time and space, and they can have participants or things that are available during the event. So then about the named graphs. So here you can see an example of how we divide our data into named graphs. So on the bottom of the diagram, you can see biography sample graph. So that's the Finnish data coming from Finnish national biography. And here we, for example, have a person proxy for a person called Albert Edelfelt, which is a Finnish painter, or was a Finnish painter. And we have types for him, so person proxy and also CDOC-CRM person class. And then if we look at the European graph on the top part of the diagram, we can see that we have a painting called Manlik Model Study from the painter Albert Edelfelt, the same painting that we have information in the Finnish biography. And then we can link these entities of Albert Edelfelt together, and that is done in the InTaVia shared entity graph in the middle of the diagram. And here we kind of connect these two proxies to this new class, provided person class, which kind of represents the Albert Edelfelt from InTaVia universal or wider perspective. And next. And then how is this entity linking done? Well, here's one example of that. So firstly, we have data from the Finnish biographies. So we have person proxy for Giuseppe Acerbi. And then we also have from the Austrian biography, we have person information regarding Giuseppe Acerbi. And in the Finnish dataset, we have information that this person is linked with all same as relation to Wikidata entity of the person Giuseppe Acerbi. And similarly, in the Austrian biography, we have the information that this person is the same as the person entity in the German National Library's authority file GND, and it's identified there. And then we can in addition take into account Wikidata, so we can query the Wikidata graph, and we can see that actually in the Wikidata, this Wikidata entity has been mapped to this GND entity with the GND ID relation. And if we use this information, we can actually infer that this Wikidata entity and GND entity are actually the same thing. And based on that, we can create the provided person entity in the InTaVia graph, and we can generate the proxy for relations from that. From the proxies in InTaVia presentations. So next. And you can see now that there's a direct connection between the different perspectives of the same person. And this is basically how the entity linking is done. And Matthias will now continue from the JSON part.
Okay, yeah. So given that we're already pretty far in time, I'm going to just quickly run you through the IDM JSON. So the IDM JSON is our JSON schema provided via the API. That's what I already showed in a previous slide. It should be a simplified version of the IDM RDF. The nodes and the entities can have attributes which they can't in RDF. And the node history is basically a relation, a list of relations to other nodes with timestamp and a relation type. So that is the role that we saw already in Jouni's slide. So how's that looking like? There's basically then so the timeline in the middle, where you see all the events that the person took part in, and the relations to other entities on the right, including the roles that those other entities had in the event, and like that we can create a more detailed picture of the person. So now I'm going to show you, hopefully this is going to work, the API live. So this is the API Swagger definition that is meant to, so it gives you a machine-readable definition of what is where and what you can query actually. And there are entity endpoints and event endpoints. And the entity endpoint, for example, here has several filters. So like, for example, you can query here for a name, and we are going to, this is not my computer, unfortunately. But I'm going to make it. So we are going to query for this Archerby that Jouni already mentioned before for the name. And there are other filters like when he was born and so on and so forth. We can also filter for the type of entity. And if we execute that, given that we have a cache, this is already pretty fast, so the results are already here, and we see that there are two results here on this Archerby. There are two different persons named Archerby in our database, but the one that we are interested in is this Giuseppe here, and we see here via the linked IDs that there is the gemeinsame Normdatei, the Austrian Biographical Dictionary, and the biography sample, and then there is the gender and labels, professions, and then a list of unreadable events that the front end has to resolve against another endpoint to get some useful information out. And we're going to look at the front end also in this case. So that's a live view of the front end, what the front end does then with that information from the API. And if you can see here, we see already these are the links to Wikidata, biography samples, so the original sources, that the gender is male, and we see here the occupations, so the German occupations, but also the English ones from biography sample. And if we scroll down a bit, we see here nice visualizations from our front-end group, and we see here these two events, for example. So you see that the first one is from a biography sample. They only have the year of birth, but the Austrian dictionary has the exact date of birth. And as you can in the front end also edit the information, you could just delete the 1773 from biography sample and use only the information from the Austrian dictionary in this case. Or you can correct it if you know that it's wrong. But the front end people are going to speak about that anyway. So I'm going to go to slides to what we are still working on. One is data validation via Schlögl constraints. So one really big problem is that our original data sources are not in the exact format most of the time that we need it into. And we learned that the hard way, that we should actually validate the data before ingestion, because if there is not good data in the data store, the data that comes out is crap as well. So the second thing that we are working on is data ingestion workflows directly via GitHub that should allow also external people to do just pull requests against our ingestion repository and add more data to the triple store. And these prefect pipelines that we already showed need to be adapted to that source data repo workflow. Yes. And then just for a few final challenges that we met during the project. So there is a problem of accuracy versus feasibility. So there is a lot of provenance data involved. And the question is, what kind of provenance do we need? How detailed do we need that? Do we need to know for every data point when it was created, who created it, when it was converted, which pipelines were involved, and so on and so forth. Then is the language problem. So as you saw in the occupations just before, we have the occupations in the original languages, and we need to somehow auto-translate that or link that so that the user can always have the same language when he or she retrieves the data. Then there is the problem with the duplicates. As you saw before, in this case it made maybe sense, but there's a lot of duplicate information on profession, for example, that is just duplicates because it wasn't translated correctly. That should be resolved. And then there's performance problem with the API. So SparkQL endpoints are not known to be extremely fast because there is a lot of very complex queries possible. So we need to introduce this caching, for example, to make it faster, but there's still problems with that. Yes, thanks very much. So there is the URLs that you could be interested in. There is this InTaVia GitHub organization where all the program code is published under MIT license. And there is the second one is the backend that I showed before, including the Swagger definition, where you could directly query it, so it's free to use. And the third one is the front end that consumes the API. Yeah, that's about it. Thanks very much.